Hello, 8th grade. So this is your extension worksheet for Tuesday. These are going to be really challenging scientific notation problems, harder than almost anything that we've seen in class. So let's persevere through these problems, and I know you guys can do really well on them. So question 1. Light travels at approximately 3 times 10 to the 8th meters per second. How far does light travel in 1 week? All right, so we know how many meters it travels in 1 second. We need to figure out how many meters it travels in a whole week. So we need to go from seconds all the way to weeks. So first I need to figure out how many seconds are in 1 week. So I know there are 60 seconds in 1 minute. And then we have 60 minutes in 1 hour. So how do I figure out how many seconds are in an hour? I need to multiply the seconds per minute times the seconds per hour, because each one of these minutes has 60 seconds and there are 60 minutes. So I'll have 360 times 60 is 3,600 seconds per hour. All right, so now I know how many seconds are in 1 hour. Then I need to go a step further. So then how many seconds are in 1 day? I know there are 24 hours in 1 day. So how do I figure out how many seconds? Yeah, I need to multiply 3,600 times 24. So 3,600 times 24. 4 times 6, carry the 2. 4 times 3 is 12, 14. So it's 86,400 seconds in 1 day. So 86,400 seconds per day. But I'm still trying to find the number of seconds in a week, so I need to take that one step further. How many days are in a week? Right, I have 7. So then I have times 7 days in 1 week. 86,400 times 7 will give us 7 times 6 is 42, 44, carry the 4, 7 times 8 is 56. 604,800 seconds. All right, so now we have the number of seconds in a week, and we know the number of meters that light travels per second. So now what do I need to do with these two numbers in order to figure out how many meters light travels in 1 week? I'm going to need to multiply them. It says approximately how far does light travel in a week, so I want to estimate my numbers. This number is already pretty easy to work with. This number is not. So I'm going to make it instead 600,000. So now I'm multiplying 600,000 and this number up here. What's different between the two numbers? Yeah, they're written in standard form. So how can I convert, or they're written in different forms. How can I convert 600,000 so that it's written in scientific notation? You will get 6 times 10 to the 5th. You get that because you have to move the decimal 1, 2, 3, 4, 5 times to put the decimal after the 6 so that your front number is between 1 and 9. So now here are my two numbers. I have the number of meters per second and the number of seconds per week. I'm going to multiply my two numbers using what I've learned about scientific notation. I start by multiplying my numbers. 3 times 6, 18. 10 to the 8th times 10 to the 5th. What do? I add my exponents, so it'll be 10 to the 13th. Am I done? No, my front number needs to be between 1 and 9, so I place my decimal here. This number got smaller by 1, so this number needs to get bigger by 1. And I'll have 1 and 8/10 times 10 to the 14th. What is my unit? My unit is going to be meters because it is the distance that it traveled in 1 week. All right, moving on to question 2. Question 2 is even trickier. It says, assume that there are 20,000 runners in New York City. Each runner runs a distance of 26 miles. If you add together the total miles that all the runners ran, how many times around the globe would the marathon have gone? So I have 20,000 runners. 20,000 runners, and each one ran 26 miles. And I want to know how many times around the globe would they have run. In order to figure that out, I need to figure out how many miles did these runners run. So if I want to know the total combined mileage that they ran together, what can I do? If you said add, you're right. I can add this 26 times, but repeated addition is the same as multiplication. So I will say the easiest way to do it is multiplication. So I have 20,000. I want to write this in scientific notation to make this even easier. So 20,000, my decimal needs to go here. How many times did I move it? 1, 2, 3, 4. So it's 2 times 10 to the 4. So I have 2 times 10 to the 4th times 26. This is all multiplication, so I can multiply in any order. So I'll do my 2 and 26 first. So now I have 52 times 10 to the 4th. Am I done? Nope, I need to make this one smaller, make this one bigger. I'll end up with 5 and 2/10 times 10 to the 5th power. That's my final answer. All right, so now, not as my final answer, as the number of miles they ran. But now I need to know how many times would they have run around the globe. And the globe, the circumference of the globe is 2 and 5/10 times 10 to the 4th miles. So what do I need to do with those two numbers? I need to divide them. So I need to take my bigger distance, the distance that they ran, and divide it by the circumference of the globe. So I have 5 and 2/10 times 10 to the 5th miles, which is the distance they ran, divided by the circumference of the globe, which is 2 and 5/10 times 10 to the 4th power. Again, I am going to approximate this. So about how many times does 2 and 5/10 go into 5 and 2/10? It goes in about twice because 2 and 5/10 times 2 gives us 5. Then I will subtract my exponents. 5 minus 4 is 1. This is the same as 20. So they ran around the globe approximately 20 times. All right, go ahead and try the last problem independently. If you think you got it correct, let your teacher know and you get a +5 for solving this challenge problem. Good luck.